Alright, today we're going to talk about pulling and setting meters. I think this is something that we kind of take for granted. We pull and set so many meters that we don't think about the hazards involved with doing so. So we're going to talk about a couple things here involved with this. First of all, we're going to talk about the qualifications of employees, proper terminology, inspection of meter bases, the hazards involved with that, identify proper PPE that we should be wearing while we're pulling or setting meters, proper use of voltmeters, how to use the voltmeter, a complete voltage check, and of course we're going to talk about the procedures when we pull and set meters. So what qualifies employees to pull meters? Well, OSHA says that employees working on equipment over 50 volts must be qualified. So let's stop and think about that for a second. Is there anything that in our industry that is under 50 volts? Even something as simple as a security light is over that. So anything pretty much in our industry that we deal with, we have to be trained to do so. With that being said, what qualifies an employee? Training. Also, on-the-job training, official training like we're doing right now. And OSHA says that in OSHA 1910-269A2 through 1910-260A27. That's the gist of it. We have to be trained in order to do so. Proper terminology of meter bases. In our industry, we have a lot of different names for a lot of different things that we use. I've referred to meter bases as cans in the past. I'm sure a lot of people have. But when we talk about a meter base, we've got proper terms that should be used. With that being said, if you notice the gray box you see in the picture here, usually it's going to be attached to a wall in a house or a building, or maybe even on a pole. That's going to be your actual meter base. That's pretty much the basic starting point for this meter base. Then you've got your lugs. You have lugs. The lugs are where our wire is going to be connected on the inside of the meter base. As you can see, you'll have some on the top, which is the source, the line side, and of course on the load side on the bottom. You'll have if you notice on the picture, you'll see the yellow portion. That's going to be your insulated post, also known as the guts. This is the part that we dread to really have to fool with too much, really, because they're so brittle. They do break a lot, very easy. And if we have to ever tighten up on anything, or if we have a problem, or if an electrician goes in and has to tighten up on a lug, if we have to kill it out and they have to actually do some work, sometimes those insulating posts break off, and if that be the case, then we usually have to change one side of the guts or change the whole meter base entirely. Of course, then you have the line side. That's going to be the top of the meter where the wires come in. The load side, of course, will be the bottom where the wires go out into either a house or a building or a disconnect of some sort. You're going to have your neutral. It's going to be located in the center. The lugs in the center. You'll have neutral lugs on the source and the load side. And of course your ground will be the copper, number 6 copper that comes in either from, depending on which hole was knocked out when the electrician installed it, could be on the right hand side, the left hand side, or even in the middle, usually from the bottom of the base. Meter base inspection, of course, is very important. We're going to be looking for socket damage. Socket damage can be caused from a lot of different things. These meter bases are out there for an extended amount of time. Trees could fall, pull meter bases off of the house, off of the building. A lot of cases, these meter bases are out there for an extended amount of time. The covers are removed and vandalized. People steal parts out of the meter bases for their own. We're looking for loose connections. Loose connection, of course, if you don't find the loose connection, and you feel you have one, you don't find it, eventually it will show you where it's located. Loose connections, they generate a lot of heat. And the problem with that is when you have a loose connection, it generates heat. That heat makes the loose connection worse. The next thing you know, it generates more heat. Of course, then usually, eventually, it will cause a problem where there's no question where it was located. Loose connection also causes insulation of the copper wires where they come into the lugs, source, or load. Could be either one. Usually, you'll find that the insulation on that copper wire to have been hot and melted, maybe even peeled back, exposing the copper strands, and those copper strands could, of course, have a color change, a difference in color from its original color when on installation. Foreign objects. To be honest with you, I've thought about this a lot and tried to figure out a delicate way to put this, but honestly, foreign objects kind of falls back on us. Just think, how many times have you pulled a cover off of a meter base to either pull or set a meter or check voltage or what have you, and cut seal, or maybe even some plastic boots where the meter had been cut off for non-payment in the past, where they've fallen out, or there's 3 or 4 of them in there, or possibly even more. Not 100% of that is going to be on us. A lot of foreign objects, we have rats and things get in there and they'll build nests, and of course those are also foreign objects. But some of that falls on us. And we're supposed to be professionals, so let's try to minimize that and keep those cut seals and boots on these meters out of there. That's not where they belong. We talk about hazards involved with these meters. Whether we're pulling or setting there, we've still got to think about what hazards are involved. And of course, this needs to be part of a job briefing. If it's if you're out there building a job and you have to set or pull a meter, this definitely needs to be part of that job briefing. When we talk about the hazards, the first one we're going to talk about is electric faults. Of course, we have a problem with that usually on everything we deal with in our industry. That's always a thought in the back of our mind. And so that we definitely need to take precautions for that. The environment, as we said earlier, a lot of these bases are left out there, and sometimes they're left uncovered, de-energized, and the covers have been removed by the public. And of course, when it rains inside these bases, and you have the heat from the sun beating on the inside of the bases, like on the insulated post, and of course the rain, the heat, the cold, the environment plays a toll on the interior parts of this meter base, and it could definitely cause us a problem. Number 3, the consumer, the customer. Honestly, I think if we would stop and think about it, the customer could possibly be one of the biggest hazards we have to deal with. If you stop and think about it, how many of you have had problems in the past with consumers stealing electricity after being cut off for non-payment, or maybe the consumer didn't do any paperwork at all and just moved into a house and cut his own power on because he didn't do the contract and membership and all that. So the consumer could be a big problem. We'll talk more about that here in just a second. I've got some more information on that. Breaking glass. Breaking glass was a big issue when there was several meters out there with glass globes. When it was pulling and setting these meters, sometimes that glass globe would break, cut through the worker's glove into his hand. The glass breaks. It's very sharp, of course, and it has caused a lot of injuries in the past. With that being said, we don't have a lot of those glass globes floating around anymore. There are still a few, but our new meters now have plastic globes on them, so that kind of minimizes the threat of that hazard, the breaking glass. Insects and varmints. This topic, I believe, I could go on and on talking about this one, as you all can imagine. We can all sit here and name insects and varmints that tend to pick meter bases to live in and been there for quite a while. And I'm sure a lot of you pulled the cover off a meter base and had to run the opposite direction because of wasps and bees. But those things they do tend to build homes inside of these meter bases, which could be a hazard for us. If we stop and think about it, we have rats, ants, bees, wasps. Things of that nature, even snakes. Now, snakes could be a different hazard if we stop and think about that. Usually, if a snake gets in a meter base, it's going to be wrapped around all 4 lugs. Usually, he's dead already. But if he's not, and you pull the cover off of that meter base, and he's going to be trying to get away from you about as fast as you are trying to get away from him. And of course, when he's wrapped around all 4 lugs, you could have phase-to-phase fault, or you could have phase-to-ground, or phase-to-phase, both. Because he's wrapped around all 4 energized conductors, and he's laying inside a grounded case. So we definitely want to be careful of that, because once we pull that cover off and he starts to move, we could have a fault. Of course, the biggest thing we want to talk about is going to be fault current. And fault current, again, is one of these things we think about. It should be one of the things we think about on everything we do. Fault current available at a meter base, something as simple as a residential meter on a house, 120, 240, 3-wire, single phase, can be very high, can be extremely high. And with that being said, fault current calculation. I'm going to explain to you how to figure out your fault current at any given location, whether you have an overhead transformer or if you have a pad mount transformer. Either one, it's going to be the same. If you're at a location, you take your kVA, you multiply it by 1,000. That gives you your total kVA. All right, you take your total kVA from the top line, and you divide that by your secondary phase-to-phase voltage, and that's going to give you your full load secondary amps. Well, secondary phase-to-phase voltage, usually at a residential application, that's going to be 120, 240. So we're saying phase-to-phase voltage would be 240 volts. We take that full load secondary amps and we divide that by the impedance of the transformer, and that's going to give us our fault current. For example, if you take this particular problem here, we have a 25 kVA transformer, secondary voltage 120, 240 with impedance of 3%. And if we plug those numbers from the problem above in the equation that we talked about, we take 25, multiply it by 1,000, gives us 25,000. We divide that by 240, which is our secondary phase-to-phase voltage, gives us 104. We divide that by 0.03, which is going to be the 3% of our impedance. 3% of 100, of course. Of course, with the percent, we have to change it to a decimal form, so it will be 0.03. And that gives us 3,466 amps of fault current available at this location. And now, from this problem, if you look at a 25 kVA transformer, 120, 240, that could be any residential application.
In real time. Now the same from different angles. And now in slow motion, we can clearly see the enormous impact of the arc.
And of course, as we can see from the video, that was a lot of heat generated from that fault located in that meter base. If you notice in the slow motion portion of that video, there was a lot of flying molten metal, that definitely is going to burn through skin, of course, in the clothing. Also, one more thing I want to mention about that video, and we noticed that in slow motion we could see a lot of detail. But if this was real life and in an actual location where you was out working, it's going to happen in a blink of an eye. It's going to happen so fast that you can't get away from it. You're not going to be able to outrun it. So that's one reason why we wear our PPE.
Measuring devices, and trying to pull a meter could be the last thing you ever do. Watch this experiment. This is what can happen when you pull a meter and it shorts out at the base. Pretty, huh? The possible burns, eye damage, or even loss of life just aren't worth it.
And of course, in this video, we noticed about the flying glass from when the meter exploded. That is one of the hazards we used to have was a big deal when the glass globes was all we used. but there are still a few floating around, so that still it could be a problem. On this particular video, this is a 5-cent piece exposed to 200 amps of current. The purpose of this video is I want you to notice how hot this 5-cent piece gets with just with 200 amps of current. And let's compare that heat to what heat could be generated from the 3,466 amps of fault current that we talked about earlier that's available. Of course, in this video, the heat is gradual. It is only 200 amps, but I think it goes without argument that this gives new meaning to this money burning holes in your pocket. So, but the 3,400 amps of fault current involved in a meter base that goes ballistic, that's going to be instantaneous heat. That's not going to be a gradual heat like we see here in this video. So with that being said, there's a lot of hands involved as far as what determines what PPE we should be using when we're pulling and setting these meters. The OSHA, APPA, the National Electric Safety Code, even your safety manual at your co-op or your utility, that they all have a hand in this. But one thing I want you to notice, if you look at this list, what do you notice about this list? Is there anything on this list that's new that we shouldn't already be using? Hard hat, safety glasses. Some utilities do require a face shield when they're pulling and setting meters, just for extra protection. Rubber gloves, FR clothing, leather gloves if it's a de-energized base. These are all things that we've already been using for a long time. We should be already using these, and so it's not like we made this, or there's not like this been this big change with this, and we've added some things that have taken us some time to get accustomed to. All these have been in place for quite a while.
Just one chance, just one
Okay, I know in this video that you just seen, I know that wasn't a meter base that he was working in, but still, if we can compare that, because we have again, we have fault current that's available. We have an arc flash event that he was exposed to, and of course, whenever we deal with these meters, we have that same threat, that same hazard. So with that being said, it's definitely comparable to the meter base. Of course, anytime you deal with three-phase and a bigger application, of course, the fault current could be a little bit different, a little bit more. Use of a voltmeter. This particular section of the program is usually handy for those that have not been in the industry very long, and maybe they haven't used a voltmeter very much. And with that being said, this is very basic, but we want to make sure that our leads are plugged into the voltmeter where we need it. If we're going to be checking voltage, we want to make sure that our leads are plugged into the right locations on the meter, so that when we check voltage, we get an accurate reading. If your leads are plugged into the wrong positions, then of course you won't get an accurate reading if you get a reading at all. So we would definitely want to make sure we have our leads plugged into the right place. These are going to be three of the main settings that we use the most. Direct current, as you can see, is going to be a solid line with a dashed line under it. That's going to be the symbol. Alternating current is going to be the wavy line, as you can see. And of course, ohms, that's going to, I've always called that the horseshoe. That's going to be your ohms symbol. These are not all the settings that we use, but these are the three main ones that we'll use a lot. Of course, anytime you use a voltmeter, you want to make sure you read the manufacturer's instructions. Not saying that you don't know how to use a voltmeter, but let's say you buy a new voltmeter and there's functions on that meter that you're not aware of. I did the same exact thing. I bought a voltmeter. I used it for a short period of time. I did not read the instruction manual with the thing when I bought it, and after a short time after I bought it, I realized after reading the instruction manual that the meter had a thermometer setting on it. So I'm not saying you don't know how to use a meter, but maybe if you read the instruction manual that comes with the meter that you're using, it might shed some light on some features that meter has that you're not aware of, and that definitely could give you a little bit of insight on it. Let's talk about procedures for proper voltage check. We're going to take, now that we've checked our meter, we know the meter is functioning properly. We've checked it on a known source. We know the meter is working 100% like it's supposed to. We're going to take that meter, and let me back up. We're going to take that meter. We're going to set that meter on the left of source to neutral, phase to ground on the source side, on the left hand side, and we should get around 120 volts. It might be a little bit more than that. We're going to do the same thing on the right side. We're going to check right source to neutral, and again, that should give you around 120 volts. If you get around 116 volts on either side, phase to ground, that's going to be on the low side. So that's going to give us another problem that we're going to have to deal with. Next step is going to be source, left and right source, phase to phase voltage here. That should be around 240 volts. Could be a little bit more, a little bit less. But that's around what we're looking for. Now, if you're getting to this point and you're not going any further, and you're setting a meter at this point, then you're taking a big chance. It's a gamble. A lot of cases we have a problem with a meter or a meter base. It's going to be on the consumer side, not on the source side. So if you're going to this point and setting a meter, you're skipping a lot of steps and taking a big chance. Our next step should be right source to right load. Again, right now we're checking for any kind of back feed. At this point, you shouldn't get anything. If you check this position, you should get zeros or no voltage at all. I'm going to do the same thing on the left hand side. Should still get zeros. Shouldn't get anything on that one. If you do get voltage or some type of reading in these positions, main thing I want to get across, I'm not really concerned so much as where the voltage is coming from. At this point, my main concern is once we see voltage in a place where it should not be, we should hit our brakes and stop, not set the meter. And now that we've determined that we're not setting the meter, we can kind of backtrack and try to figure out where the voltage is coming from. Our next step is going to be left load to neutral. Again, you shouldn't get anything here, but if you do get voltage here, then we've got a problem. Again, some potential backfeed situation. We're going to do the same thing on the right side, right load to neutral. Again, you shouldn't get anything here, but again, if you do, then you've got some problem. Then we're going to check this short on the load to load side. If you'll notice on this slide, they have the neutral and the left load grounded together. They're tied together. Of course, then they're checking the short on the load to load side. You shouldn't get anything, but if you get anything here, then you've definitely got an issue. And then, of course, this is probably the most common of the steps. Most people, including myself, I use this one quite a bit. In this particular setting, when you check phase to phase on the load side, we want to make sure our meter's in their own position. I had a situation where in an apartment complex, I was checking voltage and got to this step and found the two conductors tied together, where if I had set the meter, it would have been a dead short, phase to phase short right in my face. So when we get to this position, we want to make sure it's in own position to make sure that we're checking for continuity. We're making sure those conductors are not tied together. A little bit of confusion here that I've noticed since I've been doing this program. I've noticed that a lot of people are confused when they put their meter in ohm and they get zeros like you see here. They think it's the green light, everything's good to go. But it's just the opposite. If you get a tone or you get zeros, that means that the conductor is tied together or it is the same conductor. Anytime you get a reading or you do not get a tone in the ohm position, then that means you're in good shape. Checking voltage, there's 8 simple steps to live by. I can't put it any simpler than that. If you take those proper steps and check voltage, you should be in good shape. Again, there's other things to be considered, but we need to take all 8 steps. We need to check the voltage the way we just talked, and not take any shortcuts. Real quick, this actually would work better in an actual group setting, but real quick, scenario 1. So we get our handy dandy voltmeter that we've already assumed we've already checked it. It's in good shape. It's working properly. We've checked it on a known source. It's working perfect. We get to this position checking voltage, and we get 240 volts in this position. So that first thing that we know, we shouldn't be getting anything in this position. But we are actually now we're reading 240 volts. So now we know we got a problem. So first thing we realize is we don't set the meter. Now we backtrack and figure out where the problem's coming from. We're getting another source of power, a separate leg coming from somewhere, some type of backfeed or something like that. But again, the main thing we're trying to get across here is the fact that when you get voltage in a position where you shouldn't, is we hit our brakes. We don't set the meter. Now this one here, this happens quite a bit. Scenario 2. We're checking. We get to this point, phase to ground on our source side, and we get 240 volts. Now this could happen anywhere from the transformer down to the meter. A lot of times when we make the connection on the transformer, we could get the neutral and the hot leg crossed. They get squeezed to the wrong lead on the transformer, and that will cause this problem. Or we squeeze it wrong at the weatherhead. Do the same thing at the weatherhead, and it will cause this problem. And on the other flip side, if the coin had 3 sides, I guess we could look at it from this direction. But if the electrician marks the wires wrong coming out of the weatherhead, that can cause, and we squeeze it up, and we think we're squeezing it up right, that could cause the same problem. If we had taken the time to own that wire out before we made those connections, we definitely could have found that. But before we pick up the phone calling the electrician and saying, "Hey, I think you made a mistake," let's backtrack and check our connections at the transformer and the weatherhead, the things that we have done as a utility to make sure that we are correct before we start calling electricians. Okay, in scenario 3, we get to this point and we're checking voltage and we get 120 volts. Again, we should not get any voltage here. It should be 0 or close to that. We definitely shouldn't get 120 volts on our meter. And we do that. If we find things here, again, we hit our brakes, we don't set the meter. We've got a backfeed situation. We've got stray voltage coming from somewhere. And again, same problem here. We've got some stray voltage coming from a source that we're not sure of. And we do know in this position we shouldn't get any voltage reading at all. And the main thing is we stop at this point. We don't set the meter. And of course we get to this position here, and we just real quick, notice that our meter in this position is set in the ohms. We're in the ohm position on our meter, and we're checking phase to phase on our load side. We shouldn't get anything as far as we should get no continuity. It shouldn't be tied together. But in this case, we have it in the ohm position. We're getting zeros, and if we could hear it, then you should be getting a tone as well, and that's letting us know that these two bottom conductors are tied together somewhere. If you set a meter in this position with this kind of reading, you're going to get a phase-to-phase fault, and that meter is going to go ballistic. So why do we do an inspection on a meter base? Why do we do it? Well, we're not really sure what we're walking up on. So let's just say, for example, we have a brand new meter in a warehouse. Straight out of the box, never been used. Do we need to inspect that? I found a brand new meter in a warehouse. I pulled it out of a box just looking at it. This one here is actually a Millbank meter base. Brand new, out of a box, never been used. This is the way this meter base was shipped. What do you notice? If you'll notice, behind the cover of this meter base, the ring that holds the meter in is actually sitting behind the cover. It's sitting on top of the lugs, all four lugs, and in contact with the back of the cover of the meter base. Well, you say, well, this is a brand new meter base, never been used before. Why is it such a big deal? We don't have to really pay any attention to that because it's never been used. Well, an electrician gets this meter base. Now, keep in mind, this is the way this meter base is shipped. An electrician gets this base, he does his work, he installs it, wires it like it's supposed to be. What is he going to do? He's going to put this thing back just like you see it right now. And why is that? Because that's the way he found it. And that's what he's supposed to do. And he's doing this under the assumption that when we get there, we're going to do our job. We're going to pull the cover off this meter base. We're going to do our meter base inspection. And we're going to find this. Where in such a case where this has happened and you don't do the inspection and you don't find this and we energize this meter base, you're going to have a phase-to-phase, phase-to-ground fault. It's going to be a problem. Now, as I said earlier, a consumer can be one of the biggest problems we have. Could be one of the biggest hazards we have. Some of the photos I put in here, I just want to kind of get across to you that the internet is a powerful tool. YouTube and Google, these customers they're trying to think outside the box at this point, and they're coming up with these ways to get around what we're trying to keep them from stealing power and things of that nature. This picture here is actually a extendo stick a consumer had made, as you can see, and of course we've got a picture of the other end of it here. He was in this case he was opening and closing a fuse cutout. He was killed out for non-payment, and at night he was closing the fuse, and of course before daylight he was opening it back up with this stick. The next few pictures I've got on here I added to this program. My main, I guess you would call it my method behind my madness here is to try to get you to being accustomed to looking what you're walking into. Our inspection on a meter base, it shouldn't start with the meter base. It should actually end at the meter base. Your inspection should actually begin at the road where on the main line, on the transformer, on the connections on the service on the transformer, the actual service drop itself, and then of course ending the weatherhead, and then of course ending at the meter base would be your actual final stop for the inspection. On this particular picture, as you can see, if you was walking up to this meter to do some work, you need to notice about the booster cables that have been attached to the weatherhead. Generally, this is actually done stealing power. This is something you want to pay attention to. This is why we need to pay attention when we're walking up to these meter bases. Problems can be not just only at the base, but over our heads, and we need to pay attention. We need to look up. Same thing with this picture here. The consumer has, looks like an old service entrance to a house. And he's actually attached some copper wire, or looks like copper wire, to the weatherhead outside of our connections, and therefore getting free electricity. Again, main thing, this is a hazard for us. If we don't pay attention to this, excuse me, this could be a hazard. So we need to be paying attention to what we're walking up on. We definitely don't want to walk into a booby trap. If you'll notice here, this is another Millbank meter base. And if you'll notice in the lugs, they've bypassed the lugs on this meter base with keepers for pull pins on a trailer. Of course, some of these are pretty obvious. As we go along, they're going to get a little bit tougher. In this particular one, they've bypassed the meter using some little small piece of Romex. Looks like a 60 amp meter base. Again, booster cables used in this photo. If you'll notice, the booster cables that were put in the meter base on this one, that's pretty close. Whoever did this had some steady hands. Must have played that operation game as a kid a lot, because this is pretty close. They could have had some major issues here. But these booster cables are pretty popular when it comes to bypassing meters and stealing electricity. And again, like I said, some of these are pretty obvious. If you'll notice here, they used some yellow Romex to bypass, come out of that elbow there and tie into the weatherhead above the meter to get free electricity. All right, so this one here, if you'll notice, on the top side of the meter base here, they've got some copper that's coming off the top lugs and actually going into another coupling there, going out into some more conduit or maybe into another building. They're bypassing. They're getting electricity from the source side of the meter base here, and it's not actually being metered. This photo here is it's actually a 3-phase meter, HQ7 7-lug meter base, and the reason I left this one in here, and I wanted you guys to see this. Notice the photo to the top right, the back of the meter. It burnt every single spade off of the back of the meter. This is definitely something I'm pretty sure that we all can agree that we don't want to be standing next to this thing when this happens. Again, 3-phase fault current can be tremendous. So just keep in mind that this can happen on single-phase or 3-phase meters, either one. On this particular picture, it's kind of hard to see, but this is the reason why we look at this. Our inspection should start at the road and go into the meter base. On this particular photo, they've used some wire. It looks like Romex. Duplex to tie into the center span of the triplex. And of course, this next photo is just a close-up picture of those connections that they made. I'm assuming they stood on something, or maybe even had a ladder leaned up against the service when they made these connections. Again, the public, they're not really aware of what they deal with when they see these videos and instructional things on YouTube and Google that shows them how to do this. They don't understand the hazards involved. All right, the picture to the left, you'll see on this slide, usually you see this in a municipal situation, like a municipal lighting situation. I've done this program before, and I've heard it said that maybe this is how we need to deal with people who steal electricity. Put the meter base up and add a degree of difficulty to this. But generally, you see that in like a municipal situation. Definitely keeps the meter up out of reach of the public. The picture to the right, as you can see, is going to be they've got this meter strapped out, the meter base strapped out with some copper wire. On this one here, again, this is we really need to be paying attention. On this particular one, you'll notice the green and the red wire going into the house through the conduit and where the entrance wires are going into the house or the building. And on the picture to the right is where they've tied the other end of those wires where the meter is usually strapped out so it can register. That's tied together there. You'll see they've got the strap removed. On the inside of the house, the green and red wire was tied to a switch where they could actually open and close that manually to make the meter register. So again, this was something that was learned off of an internet video. On this particular photo here, we've got a 320 amp meter base on a house, and this one has a bypass handle. And we all know the way these bypass handles work. We raise the handle to bypass the meter base on the inside behind the meter so we can pull the meter without interruption of power. On this particular one, the handle has been bent so that the meter base the handle was actually pushed up in the bypass position, and then the handle was bent in the down position so it would look like the bypass was actually open instead of closed. So this is something we really need to be looking at real close. This one's pretty tough. It'd be hard to see. But these, like I said, the consumer could be the biggest problem, one of the biggest hazards we have. And of course, this one is a welding cable or a booster cable that's been bonded onto the service mid-span. It's kind of hard to see that in the photo. On this particular photo, the booster cable was used again. But I was fortunate enough to be at the place where this was actually the picture was actually taken, and I was told that I always thought the other end of this wire went into the window there, but I found out that the other end of this wire was actually ran across an empty lot laying on the ground, and it was actually tied to another house. And they were stealing power from a house across an empty lot. And we'll say essentially next door. And they were stealing power. So not only do we do these inspections to keep ourselves safe, but in this particular case, that wire is laying on the ground across an empty lot. It's exposed to the public, kids, children, even adults. So we do these inspections not only to help protect ourselves, but to also protect the public. Alright, with that being said, if you can answer yes to these three questions, first thing, we're going to ask ourselves, are we ready? And things to consider when we ask ourselves that question: one, is our inspection complete? Have we looked at this thing? Have we looked at this meter base from the transformer all the way to the meter base itself and looked at it close like we had discussed? Have we found anything that's out of place that don't look quite right? That could cause us a problem, maybe even set up a trap for us to get into. And keep in mind, the consumer, they're not trying to set a trap for us, but again, they don't understand what they're actually fooling with, what they're playing with, and what hazards are involved. So has our inspection been done? Is it complete? Is our PPE on? Now, notice this does not say, is our PPE in the truck? Is our PPE in the toolbox? Is our PPE in the bucket? Is our PPE on? I can't emphasize this enough. Our PPE is important, not only when we're pulling and setting meters, but in our industry altogether. You can have the best PPE in the world, but if you just don't use it, then it's worthless. So we've got to make the right decision to use our PPE. Let's make sure we have it on. Voltage check, is it done correctly? Did we take those 8 steps that we talked about when we're checking voltage to make sure that have we done our voltage check the way it should be done complete? Have we checked to make sure that we don't have a problem anywhere? That voltmeter will tell you if you have a problem if you take those 8 steps and check it the way we talked. If you can answer yes to those 3 questions, then we're ready to set a meter. First thing we're going to do when we get ready to set a meter, we're going to try it. If we can, we want to turn the consumer's main off. Now, granted, there's some cases where you just can't get to the consumer's main to do that. That's one reason why we have our PPE. That's one reason why we do our inspection process. But if you can get to the consumer's main and you can cut the main off, that's going to eliminate a lot of the potential backfeed problems that you may have when you're doing the voltage check. Second thing we're going to do is stand to the side. When we get ready to set a meter, we're going to stand to the side. We don't want to be standing in front of it. If this meter goes ballistic, so we've done everything we're supposed to do, These meters are electromechanical. You know, the electronics in these meters, they could malfunction and we would never know it. We would never be aware of that. Electronic things fail, so we want to stand to the side just in case there's something that we didn't catch. If this meter goes ballistic, we're not standing there right in front of it when it goes haywire. Third thing, we're going to look at make sure we're going to set the load side first. We want to make sure we set the bottom lugs, the bottom spades of that meter into the bottom lugs of the meter base first, and make sure those are lined up perfect. And once we get to this point, then we're going to roll the top part of the meter in onto the source side and make sure those lugs are lined up. And then we're going to push the meter in. We're not going to hit it. We're not going to draw back and hit this meter with a lot of force. Again, keep in mind these electronic meters, they're not very rugged, and hitting the electronic meters with a lot of force could damage them and cause them to go ballistic as well. So let's push the meter in, and it shouldn't take a lot of force to do that. And lastly, as far as setting a meter, we're going to install the cover and the seal. That's going to be our, I guess you could say our CYA, if you will. That's going to be our protection, our insurance. You know, OSHA says we're supposed to make an attempt to keep the public out of things like that and keep them out of the meter bases, things where these hazards exist. And of course, the cover and the seal installation, that's going to be part of that. That's our attempt to keep the public out. And then, of course, pulling the meters, if you'll notice, the steps are relatively the same. We're going to make sure we have our PPE on. We're going to turn the consumer's main off if we can get to it. We're going to do our inspection. And I know you're saying, well, inspection on a meter, we're fixing to pull. It's been sitting there. If we don't know that the consumer has not pulled that meter and maybe strapped it out behind trying to steal electricity, or maybe strapped one side out, and that causes one side of the meter not to register, so it's going to pretty much cut their usage in half. So when we get ready to pull these meters, we need to look what's behind that meter, what has the consumer done, if they've done anything, has anything been altered, to make sure, so when we pull this meter, we're not pulling and actually creating a fault or creating a problem or a trap for ourselves. So we're going to make sure, we're going to do our inspection process to make sure that we don't have that problem. Don't pry the meter at while it's energized. If you have a meter that's been there for a long time, it may be a little stubborn. And it may take a little bit of force to pull it out, but it shouldn't take a whole lot. If you have to tie a rope around that meter and hook it to the bumper of your four-wheel drive truck to pull that thing, something's wrong. It shouldn't take that. And if that be the case, you have one that's pretty tough to pull out, you can't get the meter to come out without using excessive force, then let's just de-energize it, and then we'll figure out what's going on. Another thing I want to mention here at this point, if we're trying to pull a meter and we can't get the meter out, let's make sure that it's not a bolt-in meter as well. If it's a bolt-in meter and you're not really looking and you're not paying attention, you're not going to get that meter out without causing some damage. With it being energized, that could really cause us some major problems. This next slide I've added to the program. I've taken this. I thought this is a pretty neat device. These have been around for quite a while. This is actually a meter puller, is what it's called. You can actually use this device to set or pull a meter, either one. And what this thing does, it actually grabs the meter in the front and the jaws. It will hold the meter. One of the things I like about this device, it's really easy to use. They're not very expensive, but they're really handy. They've been around for quite a while. The older versions are not as nice as this one, as you see. But the good thing about this device is if you use this device pulling and setting a meter and you have a fault condition, say the meter decides to go ballistic for some odd reason, whatever it may be, that arc is going to be, most of that arc flash that you're going to receive from that is going to be contained inside of this device. That does cause a lot of damage to it, and could possibly have to be replaced afterwards, of course. And also being said with that, this is not a replacement for your PPE that we talked about earlier. If you use this device, this is just an addition to your PPE that you already have to use. So just keep that in mind. Real quick, a review. PPE, I can't emphasize that enough. Your PPE is very important, not only in pulling setting meters, but in every aspect of our job. If you're doing any hazards, you have to think about PPE should be one of the main things in the back of your mind at all times. Use your PPE, because if you don't use it, it's just not going to do you any good. So we're all trying to go home at the end of the day. Number 2, has our inspection process been done completely? Whether you're pulling or setting a meter, we still need to be inspecting these things from the road all the way to the meter base. Has our voltage check been done correctly? We've taken all steps that we talked about, all 8 steps to check voltage, and taken all precautions necessary before we set any meters. And of course, we need to make sure that we're using proper procedures, whether we're pulling or setting meters, either one. And of course, those steps are very similar. So we want to make sure we use those proper procedures that we talked about. At this time, usually I would ask for questions during this program. It's going to be kind of hard to do in this setting. So at this time, I'm going to end the program. Thank you very much. Have a good day.